A group of bioprocessing scientists and engineers saw the need for a tool that could make data readily available to scientists on the plant floor. They knew it was difficult to get the data. Indeed, scientists were spending up to 80% of their time hunting and gathering data rather than analyzing it. This meant slower investigations, root cause analysis, and delayed shipment of product. Bio4C ProcessPad was built by bioprocessing experts for bioprocessing scientists, so they would have the right data in the right format at the right time. Bio4C ProcessPad acquires, aggregates, and analyzes data throughout the process lifecycle so that bioprocessing scientists can make data-driven decisions. Bio4C ProcessPad is a browser-based application. The user's laptop or desktop needs to be connected to the bioprocessing manufacturing site's intranet directly, or through a secure VPN provided by the customer. By virtue of being a browser-based application, Bio4C ProcessPad can be accessed from anywhere within the company's intranet. There's common access across global teams and between contract development and manufacturing organizations and sponsors for robust collaboration and reporting. To facilitate 21 CFR Part 11 compliance, usernames and passwords are unique and required to log into the system. Bio4C ProcessPad's homepage displays icons of all the software's features. We'll do a quick overview now of the menu options, and then we'll go into more detail. There's offline data, which has data analysis and visualization tools for all uploaded batch data. Reports, where users can create APQR reports, campaign reports, or data table reports. You can also create and save report templates, schedule reports, and share reports. Upload allows the user to upload batch data into Bio4C ProcessPad. Settings. Here the advanced administration and configuration settings are provided. An admin or a super admin can create products, register processes, connect to an historian, create forms, create users, review an audit trail, and add or manage limits. Machine data. This product module provides access to and visualization of streaming near real-time data from process equipment. Saved analysis. Here you can access and share all saved reports. Approve. Batch datasets that have been uploaded into Bio4C ProcessPad get verified and approved by an approver here. Stability data. This product module provides trend analysis of stability data and shelf life estimation. Now let's discover how manual batch data is uploaded into the software. Click on Upload, and here we have our forms. There are process forms and analytical forms. Process forms are batch data entry forms, and analytical forms are for entering test data, like quality control test results. An admin will prepare process forms and give access to relevant users to enter the data. A user can filter using one of the various fields here to find their form. Then click on Enter Batch Data for their form. When the dialog box pops up, they enter the batch ID. Here's our process form. To begin, the user enters a start date for the batch. All these fields will have importance when analyzing and visualizing the offline data. The raw material fields are customizable depending upon your site's requirements. A batch will have lots of raw materials. Raw material lot numbers can be added here. Entering this information will allow you to track it later in the Lot Genealogy feature. Process parameter is next. You'll see there are loads of different parameters listed. Temp shift age, harvest age, peak viable cell concentration. All these parameters are customizable according to the user's requirements and simple to edit. If there's a derived parameter, we can make the formula part of the entry field, and you can just click Calculate, and the system will automatically calculate the value using the saved formula. Next is attributes. Attributes are values or data or information which might or might not be the same batch to batch, but has some significance or value. For example, for some batches, you might have different resin lot numbers or different pH probe numbers used in the fermenters. These kinds of elements can be captured here. You could also capture here any non-conformance or root cause information, This information may or may not be in your batch records, but you can save it here for tracking purposes. Time series. For example, a fermentation may last 12 days, so each day over this period of 12 days, you'll have some sampling data. You set timestamps for when the data collection starts and ends. The age in hours is automatically calculated. All the time interval data gets captured here. You can also have derived parameters, color-coded in orange. Again, when you click Calculate, the system will automatically calculate the value based on the saved formula. You can keep adding more rows to capture your data over the time period of your process. Observations. In this field, you can note some particular happening for a batch. For example, there was a low yield for this batch, or there was a deviation. You can note this type of information here. There are two ways to submit your batch: submit as partial or submit as complete. This is useful when a batch is continuing across days, so different users across different shifts can enter their batch data. A user can submit as partial, and all his or her data is saved in the system. Then, the next shift user can come in and continue where the first user left off, and continue to enter data in the time series. Once the batch is complete, the user can submit as complete. Before submitting batch data as complete, the user must enter the end date. When the user clicks Submit as complete, a dialog box appears asking the user to select an approver. All the data entered into Bio4C ProcessPad must be verified because Bio4C ProcessPad is a validated data source. The data won't be stored to the Bio4C ProcessPad database until it has been approved. The user selects an approver and clicks Submit. If a manufacturing site is using a LIMS system or an MES or EBPR system, then these forms can be automatically populated by reading from the relevant database. For example, you could have all your raw material and QC data automatically populated to these forms. Now let's have a look at all the offline data module features Bio4C ProcessPad offers. Here's Timelines. Timelines gives you a holistic view of all batches that ran within the selected time period. Sort of a Gantt chart of all the batches of a selected product, or all products during a time period. So you can have a complete view of all manufacturing upstream or downstream batches that were executed within the selected time period. Click on one of the batches to read a card that displays summary information for the batch, such as the step, product ID, product name, process location, BR version, process equipment ID, start and end times. To learn beyond the summary information, click on View ERecord, which gives a detailed view of the batch, all the raw material, performance parameters. If there are any limit excursions, they'll be highlighted in the ERecord. At the top of the screen is an advanced filter, which lets a user filter on text, for example, contamination. Click on the highlighted batches to view more information. Note also that here you can see any previously entered observations. This can help in investigations. For example, if a batch is contaminated and you have common raw materials for several batches, for example, a media lot, you can check in the particular time period if there were any other batches running in the plant. The lot tree view provides information on two different genealogies: batch and raw materials consumables. Let's build a batch lot tree view, which helps visualize the genealogy of the full batch in production, from the first unit operation to the last, giving a comprehensive view of upstream and downstream operations. It provides information about the inputs and ingredients, raw materials or product intermediates, for each stage and process of the batch. A user upstream, or in the seed lab, may not have visibility into what happened at steps before or after their step. You can zoom in and zoom out of the genealogy view. At a glance, we can see what was the step previous to the current step? What happened in the chrome step? What was the media at this step? What seed batch went into this batch? We can also click on each step to view the ERecord. If you have trouble in a current batch, you can go and see if there were issues in other batches with similar media or inputs. Here we have Show Network, a great visualization tool which highlights the paths from one node to another. You can click on any of the nodes to see the ERecord. You can also click on a line between the nodes to turn it red. This visualization can spotlight a connection between two nodes, which can be helpful for an investigation. We can also download this visualization and add to a report. A lot genealogy visualization for raw material consumables helps to track all the raw materials and consumables going into a particular batch. Let's take as an example, if you have a media lot and you wish to find out in which manufacturing batches this media lot was used, then select the media and lot number and click on Plot. Within a few seconds, all manufacturing batches in which our media lot was used will be displayed on the screen. This narrows down your search and prevents you from having to look at all the individual batches and BPRs. Additionally, the user can click on a particular node to see the ERecord with detailed information about how the batch performed, whether some parameters are outside the desired range. You can download the image to share it with other stakeholders, or add it to a batch report. Profile Overlay. Time series data can be viewed in Profile Overlay. For example, bioreactor pH, viable cell density readings over 12 days. With Overlay, you can compare time profiles of multiple batches for one or more parameters. For example, 5 different fermenters. What was the glucose level, ammonia level, etc. We can change the parameter using the drop-down list and select a different parameter across all the batches. Users can also zoom into the charts and read the data labels with interactive features. In Advanced option, for example, we can monitor the impact of different equipment on manufacturing batches. We could see the average for particular equipment. Let's plot a 3SD, or standard deviation, and the graph will show the 3SD line for the particular equipment. Here's the 3SD line in dotted red. Here we can observe for equipment 1, there is a 3SD outlier for one of the batches. If you want to see the average for equipment 1 and 2, you can deselect all these other variables and see the average. In this way, you can easily see the profiles for equipment 1 and 2. You can get a table view of your data. Click on Copy Table to export the data to a spreadsheet. With Batch Trend in Profile Overlay, you can visualize multiple parameters in a single batch. In an investigation, you may want to understand the relationship between multiple process parameters. For example, trends of glucose, lactate, ammonia, etc. in a particular batch. You can see all the parameters in one single plot. You can choose another batch from the drop-down list and view all the parameters in that batch. If you wish to deselect any parameter, you can click on that parameter, and it will be removed from the chart. We also have control charts functionality, which give insights into batch-to-batch variability. This is often used as a part of statistical process control or statistical quality control to check and monitor whether a batch is in a state of control. Are there any outliers in the batches? There are 2 types of control charts: analytical and process. Limits in these control charts are either database limits or statistical limits. Statistical limits get automatically plotted based on the standard deviation of the data. With database limits, data is plotted based on previously set control limits defined for the process by the users. Let's choose database limits first. Looking at a control chart, we want to see how the process is doing. Is it in control? Is it out of control? What is the process capability? With this control chart, we see the upper specification and lower specification limits between the red lines, with acceptable ranges between the green lines. The gray line represents the target values. To check to see if the data is normally distributed, click on the Normality check at the right. Bio4C ProcessPad's normality check of the data can quickly tell you if your data is normally distributed or not. Before looking at control charts, you need to make sure that your data is normally distributed. This test answers the question. If the data is not normal, you can flag the parameter and note that it's just a one-time thing. Then, for whatever data is gathered for that one parameter, it will be considered non-normal. Click on Advanced Options on the right and see the Nelson rules. Nelson rules are industry-accepted and defined statistical rules which can tell you whether your batch is in a state of control or not. Let's select some rules. And also calculate capability. View the control chart to see if any Nelson rules are violated. Here's a Nelson Rule 1 violation. This means that a point is more than 3 SD from the mean. And here's a Nelson Rule 2 violation. 9 or more points in a row are on the same side of the mean. View the process capability, or CPK. If the CPK is greater than 1, the process is well defined, and parameters are in control and within the limits. With the same parameters and same batch combinations, now let's look at what we visualize with statistical limits. Here's our control chart. Again, we can see the Nelson rules violations. In Advanced Options, here you can phase by attributes, for example, pH probe, and you can visualize all the attribute data captured in the forms. We can see a bifurcation of the data. We can see for this particular probe how many different batches used that probe. It's a good visualization of probe-to-probe variability. Going to Advanced Options again, choose Ad Hoc, and create phases for each campaign. Select batches for each campaign. Plotting this data will show any campaign-to-campaign variability. Control charts analysis is critical for continued process verification, or CPV. For each parameter which has been identified as a critical process parameter, this control chart analysis is required. Bio4C ProcessPad does the control chart analysis automatically in the background, and any rule violation will send an automated email alert. Relate parameters provides visualizations that can be used to study bivariate and multivariate relationships between different batch parameters. Additionally, you can perform correlations and visual exploration of data tables created within the application. Here are all my available data tables, and also any raw data tables available within Bio4C ProcessPad. Let's choose a data table and click View Data. Bivariate displays the relationship between two batch parameters. Select the first parameter from the x-axis dropdown, and the second parameter from the y-axis dropdown. Based on the selections, a relationship chart will automatically display with statistical parameters such as R-square, p-value, and a regression line. Our scatter plot with these x and y axes shows a positive correlation between the parameters, viable cells, and age. We can add a cluster color from the drop-down menu as a third dimension to the chart. Let's choose Tighter. Here we are choosing one more batch parameter and adding a color gradient scale based on this parameter. We gain good information in this Relate Parameters tab. For more parameters, we choose Multivariate. We can do a maximum of a 10 by 10 matrix of parameters. We see a matrix of all the selected parameters. We can then choose how we want to visualize with a cluster choice, for example, the batch number. And all the batches will be visualized in the matrix. This will give us the p-value and the r-value. We can see the individual pairwise correlation for the parameters in the matrix, and you can see the p-value for it. We can also run PCA, or Principal Component Analysis, on our data. PCA analysis enables quick identification of outlier batches within hundreds of critical performance parameters and quality attributes at any stage of the process lifecycle, and helps determine which process attributes are contributing to process variability. Here again is our data set. We'll click on PCA. Under Observation Batch ID column, we'll use our unique identifier, such as the batch ID and age. Next, we'll deselect any columns that have missing data or empty cells, and any columns with non-numeric entries. For example, the product name, location, start dates. Then click Results. Here's an error message stating we've missed something in selecting our parameters. Bio4C ProcessPad highlights in red any parameters that either are missing data, null values, or have non-numeric characters. We'll deselect these highlighted rows and then click Results again. And Bio4C ProcessPad will quickly create our PCA plots for us. Here's our PCA scores plot, and we can see some outliers here. We can mouse over on these points and get the lot numbers. Clicking on these outliers brings up the top 10 contribution plots for PC1 and PC2. For PC1, the top causes of variation are lactate and glucose. And for PC2, the top causes of variation are glucose and glutamate. On the scores plot, we can quickly see that PC1 is capturing 40% of the variation, and PC2 is capturing 30% of the variation. So there's more weight on PC1, and therefore lactate and glucose may be the root cause for variability. Here's the loadings plot, which shows which variables have the strongest influence on a principal component. Loadings will tell the relationship between the parameters. You can also see the anti-correlations between them. So, across these axes, we can see that glucose is anti-correlated with age. You can also apply cluster color to get a good visualization of your parameters. Here we can see different culture phases. Here's the Hotelling's t-squared plot, which plots the Hotelling's t-squared statistic for all batches. Hotelling's t-squared presents a type of control chart. It's highlighting the outlier batches. Here's outlier batch 117, and we can see it as an outlier also on the scores plot. Here again is outlier batch 263, and here it is on the scores plot. Hotelling's t-squared is plotted against PC1 only. The scores plot has PC1 and PC2 together. The red ellipse on the scores is the same as the red line on the Hotelling's t-squared plot. The SCREE plot displays how much variation is captured by each principal component. We can see that the first two principal components are capturing almost 70% of the variance. So we can reliably interpret from these two components the variation in the model. Click on the Show Table icon to see the scaled and mean-centered data. This data is pre-processed automatically by Bio4C ProcessPad before loading the data into the PCA model. If we click on Show Table icon on the scores plot, we can see the scores of the individual components for each observation. It is the same for the loadings. For each parameter, what are PC1 loadings or PC2 loadings, etc. In the same way, we can look at all the data for each plot. We can download all these plots. Simply select the plot and click on the download icon at the right. This way we can share the plot or put it into a report. Clicking on this box plot icon, we have Compare Groups, which allows us to analyze group-to-group variability and trend parameters. There are two types of compare groups. Plot, which allows users to compare different groups of process batches across products, facilities, processes, or conditions. And Table, which allows you to create ad hoc data groups to perform statistical comparison of groups to identify significant differences. For example, if you have a process development batch and a production batch, then you can create these two groups and see how your product ran on a process development scale and how it ran on a production scale. That is, after scaling up, what are the differences and what are the similarities? So you can do a lot of comparisons and troubleshooting. For a plot group compare, we'll create a group. I've already created these 3 groups. Let's create one more. Let's select Product, Location, Process, and Step, and then add some batches. Next, we'll choose a parameter. And finally, name the group. Now we'll click View Charts, and our box charts appear. Here, we have a visualization of our groups with which to make comparisons. We also have line charts. You can select statistically how you want to view the line charts. We have trend charts to which you can make the same statistical selections. There's also bar charts and ANOVA. Note too on the right that we have the ability here to view the data as a table, download the visualization as a PNG file, save the analysis, change the chart settings, and save this query for later. The last icon in offline data is ERecords. Here you can view the process batch and analytic test records uploaded in the form of a printable report. Let's look at a process batch ERecord. You would select your product, location, process, process step, conditions, and batch. Then click Plot, and your ERecord displays. You can download the ERecord as a PDF. CPV reporting is a tedious task. It involves collecting data from all the batches executed in a time frame and trending them with statistical control limits, calculation of process capabilities, and adding any statistical rule violations, and more. Bio4C ProcessPad can automate the process for CPV reporting. Creating report templates is straightforward. At the top of your screen, click on New Template and select Campaign Report. Select your product, location, process. Click Next. Select Step, and your parameters for the step display with color coding. Alert limits in green, action limits in orange, specification limits in red. Parameters without limits are in black. Let's select some parameters and add to the final list by clicking on the arrow. Click Next at the bottom of the screen. We can see a campaign report with the product, location, and process, the step, and the parameters. Click Create a Report and name the report. Now this report is available in My Templates on the reporting homepage. Creating a report template is a one-time task, and then you can reuse the report template with new input datasets. Reports can be generated as an instant report or as a scheduled report. In the list of report templates, click on the Generate icon on your report. Select a time range. All the batches in that time range will display. Choose all the batches or a subset thereof. Select Yes or No on Show Trend Rules and Show Process Capability Index. Click Create Report. Your report is running and will be available as a link in My Templates. Here we can see the report is running. Your campaign report will have a summary of all the batches that were part of the report. A batch genealogy, and a batch list. Control charts with trend rules and any rule violations, CPK and PPK, and raw data tables. Reports can be downloaded as a zip file, a Word document, or a PDF. Scheduling a report is easy. In the list of saved report templates, click on the Schedule Report icon. Select Reference Step. Click Next. Select Batches step. Choose Fixed Batch Number, or a fixed time range, every 3 months, 6 months, or 12 months, or Fixed Date. Schedule Select Frequency, daily, weekly, monthly. Again, you can select Show Trend Rules and Show Capability Index. Scheduled reports can be viewed in the list of templates in the Links column. All the process equipment data coming from the data historian is managed in the Machine Data menu. Here we can analyze and visualize live streaming data coming from machine sensors, pH probes, etc. Plant View provides monitoring of the status of different batches that were executed in the plant. Things such as, for a given time frame, what is the total number of batches running in the plant? Their start times, end times. First, we define a time period. We have shortcuts for 8 hours, 1 day, 7 days, 1 month, 3 months, 6 months. Select a template. Then click on Proceed. Now we can view information on all batches that were executed in the plant, which group it is, which unit operation equipment, which batch, start and end times, duration in hours. We can see 2 batches are running, these batches highlighted in green, and the remainder have completed. We can see their start and end times and total duration of the batch. We can also see the utilization of the equipment in the plant. This can help in better planning. If we know that a particular unit operation is only 40% utilized, we can change our planning to get better use of the equipment. Click on the Summary view here. Select Plant to see utilization of the different unit operations. Here we can see that RE100 is at 87% utilization, and RE200 is at 84% utilization. While we're here, let's note the icons to the right of the screen. Wherever we see this table icon, this means we can get a table view of the visualization and read the values in a table. Here again are the Download and Save Analysis icons. In Machine Data, Equipment View lets us look at live streaming data coming from process equipment sensors. Equipment View shows us the profile of different parameters. For example, if a bioreactor has multiple different sensors, such as partial pressure of CO2, oxygen, pH, temperature, DO, all of these can be monitored using this view. With Equipment View, we can visualize the current trends of any equipment of interest. It also allows us to compare parameter trends for different equipment belonging to different facilities. This is helpful for troubleshooting equipment-related issues, to know exactly what happened at a particular point in time of our equipment. For our equipment of interest, we'll select the parameters we wish to view. The axis type is whether we want our parameters plotted on a single axis or multiple axes. Click and drag over a time range to zoom in on the data. We can add this view to our dashboard by clicking on the Live icon to the right. These views can be shared on a large screen on the production floor so that operators can monitor the equipment live. In Batch View, we're looking at the data from a batch standpoint. That is, for a particular machine, we're looking at data on the machine to analyze specific batches. With Batch View, you can plot multiple batches, one on top of the other, and overlay them and analyze the profiles. If you're running a batch in Facility 1, and Facility 2 is in some other country, and Facility 3 is somewhere else, you can actually plot all of these batches on a common graph and compare the performance of Facility 1 versus Facility 2 versus Facility 3. Batch View provides streaming data from all connected process equipment sliced according to process batch times. This is useful to compare the batch trends in different equipment and to ascertain if there are any differences in the trends attributable to, for example, equipment differences, processing times, or batch events or phases. In the Event View tab, the user can view events or phases that occurred for a batch. Here we are looking at the same information, but, as an example, we are looking at it with respect to the phases in the bioreactor. For example, in our visualization, we can see the different bioreactor phases: material add, agitation, heat, dwell, cool, etc. We'll be able to see the same information across different phases for different batches. And we can compare between the batches. How long did this phase last? When did it start? How does the concentration, one of our parameters, change as the phases change? Aggregated Stats allows us to calculate summary statistics for machine data. Using this, we can aggregate time series data of a batch to a single point metric. For example, we want to compare what is the maximum concentration in batch 1 versus batch 2 versus batch 3. Or we want to know an average of those concentrations. The visualization will provide us with a control chart of the average and the maximum concentration across the selected batches. We can change the aggregated statistic from the drop-down menu. Exception reports in machine data can help you monitor the batches without having to look at the real-time trends. We're setting up a template and telling Bio4C ProcessPad to do the monitoring in the background. So we want the software to tell us, during a run of a batch, how many times did agitation go outside the limits. If our limit is 100 and agitation shot up to 120, we would like to see that exception report, and we want to know when that happened and for how long. Let's choose Report Mode. Equipment, Template. A user with administrator privileges will create the exception report template. Batch, and run the report. Here's the exception report. It begins with a summary of the batch, phase information, and here are excursions. Note there were 3 excursions during the agitation phases. Here's when they started, and here's how long they lasted. This exception report can be downloaded as a PDF and shared with colleagues, or attached to a batch record if needed. Machine data also has ad hoc reports. In ad hoc reports, a tabular report is generated showing values of all the parameters selected in separate columns for the selected batch, or time range, and process unit. Here's our ad hoc report. The first section is a summary. The first column is the timestamp. The following columns are our y-axis parameters choices. Clicking on Copy Table downloads the ad hoc report in a spreadsheet format. Clicking the PDF icon downloads a PDF version of the report. In Bio4C ProcessPad's Machine Data module, you can create dashboards. These are different visualizations that we created in the various chart views. Offline Data Profile Overlay Batch Trend, Machine Data Profile Overlay, Machine Data Equipment View, and Machine Data Batch View can all be pushed to a live dashboard. We can display a maximum of 6 charts at a time. If on the top right of a chart there's a red dot, this means that the batch is completed. If on the top right of the chart there's a blinking green dot, this means that the batch is live. This is a golden tunnel view. We're monitoring a parameter against some golden batches. Golden batches are batches that performed exceptionally well, and we are looking at the performance of a current batch or an historical batch in reference to these golden batches. In Bio4C ProcessPad, admins can define golden batches and golden tunnels. In the software, you can define a maximum of 15 golden batches per golden tunnel. If the parameter is within the bounds of those 15 batches, that is, within the golden tunnel, you can have a very strong confidence that the batch under observation will also perform well and the parameters are trending in the right direction. You can share the dashboard or generate a public link. This dashboard can be displayed on a large screen on the plant floor, where operators can monitor equipment and different parameters with it. Without a structured process data management tool, bioprocessing scientists spend over 80% of their time hunting and gathering data, and only 20% on analysis. With Bio4C ProcessPad, scientists can spend as little as 15% of their time on data capture, and over 80% on analysis, enabling timely CAPAs, quicker release of quarantine lots under investigation, improved productivity, and process monitoring. Bio4C ProcessPad software is a data collection, visualization, and analytics software platform that facilitates 21 CFR Part 11 compliance and enables bioprocess monitoring, lifecycle management, reporting, investigations, and continued process verification, CPV. Intelligently combining process data from disparate data sources such as batch records, quality control results, standard databases, QMS, MES, LIMS, and data historians into a single contextual integrated data source. Bio4C ProcessPad ensures process information is current, complete, and accessible throughout the product lifecycle. The out-of-the-box data visualization and analysis tools mean users don't need to be data scientists to understand, explore, and analyze their data.